Hi, my name is Abdullah Khan. My role ID is 232975, and we're gonna do the class participation task, which is to explain the lecture number 0, Introduction to Computing. So, we are seeing on the slide what actually the computer is and how it works and what are the things that are included in the computer. Basically, we this is our first lecture of microcontroller. As we are saying, internal organization of components, the different parts of computer, which includes IO, which is input output memory, CPU. And the second point is connecting the different parts, connecting memory to CPU, connecting input outputs to CPU, and how the computer works. Basically, this explains us how the things in the computer work, what is CPU, what is memory, what is input output, and what are the other things that we can connect to the CPU and the input output devices that we connect to the CPU. All these are things are explained below. This is CPU, memory, IO. First, we will explain what is IO. Input output. Basically, input is any device that we connect to the computer, which includes keyboard, mouse, sensors, and some other devices, which includes like our webcam, our Bluetooth speakers. These are the things that we connect to the computer. And output is basically something that is computer is giving to us as a result of giving the input. Like we can say that giving the potential to the computer. So output is equal to LCD, printers, hands of robots. These are the outputs that computer give to us. Sorry. Everything that can store, retain, and recall information. This is talking about memory. What actually the memory is? Memory is anything that has ability to store the information, store the data, store the structure, and store the algorithm. This can be hard disk, a piece of paper, we can say in general words, like this is the storage memory in which in which we makes the notes, and that's notes work for us as a memory. In the same way, hard disk, USB devices, USB device is actually input device as well as memory device as well, because it has ability to store the data. And we know USB, SD cards, these cards and all these things come in the different ranges from 1 TB to 128 GB, 16 GB. These are the things, these are the ranges that comes for the USB. And the capacity. What is capacity? Capacity is actually the number of bits that a memory can store. Like it is basically, we can say that it is the number of bits that a memory has to store the data. In the same words, what is organization? Organization is actually like these all things are related to memory. Okay, first we have a bigger block of memory. As we go from down from as we go up the pyramid from down to up, we can say that the first block that we have came to face is access time, then organization, then capacity, and then we have the memory block. Because memory is something to store data, but at the back end there are some of the functions that are performing for storing that data. That includes the capacity, organization, and access time. I have explained the capacity. Now talking about the organization. What organization is? Organization is to store the data in the different bits. Like we have to say no, like we know, as we cleared the DLD course, and we know that in bits our data is in 1 or 0 form, and like binary form. Now the location, how the locations are organized is actually 128. Like if we have 128 kilobytes, okay, like we have this, and then we have 4 bit of memory. So 128 into 4 memory has 128 location bits each time. And access time is actually how long it takes to get the data from the memory. So moving on, what is semiconductors and non-semiconductors? Semiconductors are like our these devices, these disks, and the non-semiconductors are these are our floppy disk, floppy disk and other devices. Now, what is RAM and ROM? RAM is actually read-only memory. Its work is to only read the memory, and RAM is random access memory. What's the difference between ROM and RAM is ROM is read-only memory and RAM is random access memory. Now the ROM comes in the different parts like mask ROM, PROM ROM, EEPROM ROM, and EEPROM ROM, flash EEPROM, and the RAM is SRAM, DRAM, NVRAM. So what is PROM? PROM is programmable ROM, EROM is erasable ROM, and the other one is electronic erasable PROM. And RAM is static RAM, dynamic RAM, and non-volatile RAM. These all are explained in detail in the further lectures. Now programmed by the IC manufacturer. Moving on, as we know what is OTP. OTP is one time programmable, like you can use only it for one time. As giving the example of OTP is like most of our banking apps, when you paying the bill, when you are paying to anyone, most of the time when you access into a new device, an OTP is sent to your SIM card. So that OTP is either accessible for only one time, and it sometimes even most of the times it comes with the some time duration like 30 seconds, 15 seconds, and in some cases it is automatically accessible, like you don't have to put OTP. When OTP comes to your device, it automatically sets on the algorithm, and then you have access to the other things. What is UV EEPROM? Like UV EEPROM is old device that is used for like ROM, and these are the things. Now in modern era we can erase the data by using ESET or or by using the like reset button, or by the algorithm which gives access to reset. But in the different era, like in old era, we have these type of UV EEPROM. What actually these EEPROM is and how it works is you store the data in this EEPROM, these functions, and when the data is filled or you don't need that data, what you actually do is you put it in the sunlight for or any other light for like 20 minutes, and after the 20 minutes the data is automatically erased from the device. These are UV EEPROM. And erased electrically, these are erased electrically. Each byte can be erased by the separately, and erased in the flash, the entire device is erased at once. What is erased electrically mean and erased in a flash mean? Erased electrically means you have like you can this can like erase the data instantly. You can like, or you can say that you can erase each data separately. Okay, erased in a flash means like you your all the data can be erased at once. Now moving on, as we have explained earlier, what is RAM and ROM is, that is one thing that I'm not gonna explain now because I have explained it with the detail above. Now what are transistors? Made of flip-flops. Made of flip-flops, we like in DLD we have explained, we have learned, we have like thoroughly studied about flip-flops. There are different type of flip-flops like T flip-flop, SR flip-flop, D flip-flop, and different type of latches. Now and master slave flip-flop, these are the types of flip-flop. Now we're gonna talk about the advantages and the disadvantages. What are the advantages? They are faster, no need for refreshing, because flip-flops are meant to replace the latches, because in latches we have the timing issue. And what are the disadvantages? They have high power consumption and they are expensive. Now, made of capacitors, advantages and disadvantages. As we know, capacitors, they have less power consumption, they are cheaper, they have high capacity. And disadvantages are they are slower and refresh needed. Made of SRAM, battery coil control circuitry. Advantages, they are very fast, infinite program, erase cycle, and the disadvantage is expensive. Now we have like device in which we have memory pin out, reading from the memory. We have like graph which has CSOE, data, WE, time graph, read from the memory. Now CPU should have lots of pins. Why CPU should have a lot of pins? Because it needs to connect all the different devices at once, like mouse, keyboard, sound card, graphic card, network. Now I'm gonna explain how the CPU works. This is like a block diagram in which we have address bus, data bus, and control bus, which reads and writes, and CPU with input output 0, input output 1, input output 2, and input output to the nth. These are actually the like we can say that ports in which we input and output devices. And this is like the CPU address bus and data bus and the control bus. And this is like seeing that how the AO is going to the N and then going back and forward to the CPU and to the chip. How could we manage it? Now we are going to explain how the things work in CPU with that address and all other forms. Basically, when a port is selected, for example IO 0 port is selected. Now on the 0 port is selected, if we have to give any data or we have to take any data, the IO port address is used, not IO1, not IO2, neither ION port, only IO0 port is used, because that data or that address is used for the for the CPU. And we know that like this comes with a bit of memory, and all the data works, whatever the thing is located on IO is transferred to the CPU, or from the CPU to the IO if you have to transfer the data or to the IO, because we see it earlier, because this is the thing that I am talking about, in which IO and OI you have to give access to the both CPU and IO. Now we have the address bus, and from the address we can see that it has a logic gate circuit, and the logic circuit is working. Now as we have in detail studied about conversion of binary into decimals, decimals into binary, this is like how the normally they works, like most common bit to most significant bit to least significant bit divided by 2. And for decimals you have to make the multiples of 2 and then add them. This is hexadecimal system, in which we can see that in hexadecimal, like it's a proper algorithm of the of the number system, decimal systems, number system that include decimal, binary, and hexadecimal. These all things we have already explained, have learned in detail in the DLD. So we're gonna not talk about this. This is our like the some of the common examples in which we have addition, multiplication, RC units, and all other things. Now this is the main thing that we're gonna talk about. What is this? This is actually how the things work in the CPU. For example, if now moving on, this is the address bus, and this is like if we select the port number 17, what actually is gonna do is any address that is located at the section A is transferred to the memory bit A. Now we can see that beside with the CPU there is like registers A, B, C, and D, and this like table with the blue scroller is how the things work, and all the data from 0 1 2 3 4 5 6 7 is gonna transfer into the instant deck 30 instant deck. So if we choose 17, what actually on 17 is I is 0, starting from 0. On the 0 there is an entry of 31H, so 31H is transferred at instant deck. Now moving on at the 1, so at 1 the A17 address is go and like on that, and then the port number 9 is transferred. Moving on, so a data of number 9 is transferred on the A bit. In the same way, C30 C4H is like moved on and then on to the B, because there is an thing in which we can say that on B we must have the data of A, so B bit have the data of A, and the A comes with a new entry of E. The E comes because the number is changed into the hexadecimal, and that is how the whole thing operate. And then we have the Harvard architecture and non-Venom architecture. This is like the architecture in which we can see that CPU have access to the data bus of both data memory and CPU code memory, and like this is the diagram which is explained very neatly. And then we have microprocessor and microcontroller. Microprocessor has no RAM, ROM, IO ports on chip itself. Example: Intel Power PC, Motorola, Spark Sun applications, desktop, laptops, workstation, servers. And microcontrollers comes with the microprocessor, RAM, ROM, timers, IO ports on a single chip. 8051, like these are the microcontrollers which are used on the micro level. And these are the some of the sites and some of the things that will help you to gain the knowledge about microcontrollers and processors. Now what is speed? Like we know speed is the highest speed of the microcontroller is like higher. What does it mean? It means that the speed to access the data and packaging, power consumptions, these are all the things that we're gonna talk about and that we gonna learn in microprocessors. Now this is all the data as we explained earlier, and this is like the block diagram, and this is the end of our lecture.